the total amount of cars during time equals to 7 to time equals to 9 is about, and then we got this number earlier, it's about 2549, or you can say 2550. So either number would be okay. All right. A couple of definitions. One of them is displacement versus total distance travel. Now, displacement, the definition of displacement is the change in position. So there are two ways to, there is displacement and there's also total distance travel. What's the difference between the two? When we calculate displacement, then we just find the definite integral of the rate, whatever the first derivative is, and that's the displacement. In this case, is velocity is the first derivative. When we're finding total distance travel, we have to take absolute value because we also count backward distance as a distance travel, and therefore we take the absolute value. So make sure you know the difference between displacement, just regular displacement, and total distance travel. Total distance travel, make sure you put absolute value around the velocity. Okay? All right, so here is the velocity of a particle, which is the first derivative of a position function. It's given to us, and it says find the displacement and then find the total distance travel. And so to save time, I'm going to use a calculator to figure this out. But the setup is important, okay? So the displacement is 0 to 6 of the function v of t dt, and this is v of 6. So we're going to use a calculator to find out what that is, to find the definite integral using a calculator. Start with math, option 9, and then type in 0 followed by 6. Now type the function into here. So the function is t cubed minus 10t squared plus 24t. So t cubed minus 10t squared plus 24t, and then dx, and that gives us 36. 36, okay? So this is 36 feet. Okay, so we would say that the displacement from time 0 to time 6 is 36 feet. What is the total distance travel? Okay, well, here's how we find the total distance travel. It's from 0 to 6, and then the absolute value of the function. Okay, and that's how we find the total distance travel. And so we go back to the same problem and math 9. Okay, now what is v? But whatever v is, we have to put that in absolute value. So start with the absolute value function, math, and then absolute value. And we're going to type in t cubed, t raised to the third, followed by 10t squared, followed by 24t dx, and then it gives us the total distance travel, which is wrong because I forgot to put a plus sign between the x cubed and the 10. So let's go back to our equation, and then we're going to insert a plus sign. There you go. And the total distance travel. So make sure everything's good here. X, oh, that's a minus. Sorry, my mistake again. Then that should be a minus. That gives us, it is still working. It is still working. 49.33. So 49.333 feet. And that is the total distance travel by this particle. The displacement is 36 feet, but the total distance travel is 49.333 feet. Okay, good. All right, so let's take a look at the last, one of the last problems, or the last problems in this lesson, which is a problem that deals with looking at integral as a net change. So, traffic flow is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by this function. So this is the rate. This is the first derivative of some function. And we want to know, these are cars per minute. T is measured in minute, and we want to know how many cars passes through the intersection over 30 minutes. So to determine the total amount of cars, here's what we do. We go from 0 to 30, and then we integrate the rate function, and that gives us the total amount of cars that passes through the intersection in the past 30 minutes. So let's do that. Make sure we are in radian mode, which we are in radian mode. Go back here, quit, start by going math option 9 right here, math option 9. That brings up this integral. Type in the lower bound followed by the upper bound, and then type in your rate function, which is 82 plus 4 sine t over 2, 4 sine of t over 2, close up parentheses for that, and then x, and this should give us, so this should give the number of cars that pass through the intersection in the past 30 minutes. So about 2,474 cars. So 2474.07678. So we say that cars. So about 2474 cars pass through the intersection over the 30-minute interval. Okay. Is traffic flow increasing?